Oops. Oh, good. Thank you. I don't know who's doing that. If that's is that Magali or somebody? Thank you. Um, we do have a speaker tonight that I'm excited to hear from. She comes to us from WSU, and it is Abigail Chapman. So she will come in probably just before 7:30 when our speaker usually starts.
Well, thank you.
Oh, you're here. Oh, hi. Are you Is that Abigail?
I'm having issues as well. So I got like a message to update my Zoom. So I'm here, I'm listening, but I just can't see anything.
Okay. Well, we usually have someone who does a beginner lesson for us, and I did it last month, and then this month I just don't have one, and I gave my winterizing one last month. Um, so does anybody have any? Oh, hi, Bill.
Hi, I specifically wanted to ask you a question.
Sure.
Actually, so I do need to leave early tonight, but I did want to be here for this part. So in one of the bulletins, maybe the most recent, you were talking about adding granulated sugar to a hive, and I think you said once a month. I wanted to find it before I asked the question, but I didn't have time.
Yeah. So what I do is I kind of load them up with dry sugar. If you've got a shim, an emery shim, you can put newspaper on top of the frames and put dry sugar on top of that. But if you go to refill it, you have to put a new piece of newspaper down, and it kind of makes like a newspaper sandwich of sugar, newspaper sugar sandwich. Otherwise, the new sugar will fall through the holes that the bees chewed in the paper. Now, that's what I was up at the apiary doing today. Is some of them I had to put a second layer of newspaper and add a little more sugar. I what I do is I keep adding sugar periodically this time of year, because this time of year they're still active. They were out flying, a lot of bees out flying today and bringing in pollen even. But as soon as we drop down to that 55-degree temperature, then the bees start getting a lot less active. And so we're going to probably around November. We're going to have an exceptionally cold and wet year this year, with NOAA says probably a lot of snow. We've got an El Nino coming in. And so then I check the bees once a month. And if they're running low on sugar, then I top them off. And and then in February, I start checking twice a month, because that's when they start brooding up, especially if you have Italians or some type of bee that has really large colonies going through winter. Then they might go through a lot of food, and the risk there is that they would suddenly starve to death in April, which happens sometimes.
Right. Okay. So if you're checking once a month, like I guess how much sugar are you, let's say, pouring on top of the new piece of newspaper?
Um, let's see here. Um, I went through 100 pounds in 6 hives today.
What?
Yeah, yeah. They took 4 bags of sugar. Now they were all completely empty. They had all. So I put on sugar a little earlier than most people, because I don't like to mix 2 to 1, and they seem to take it and pack it, liquefy it, and pack it away just fine. So I've been giving them just granulated sugar for quite a while, and they were completely empty. They eat it all up just as if it was 2 to 1, but it doesn't put all that extra moisture in the hive.
So is when you put the newspaper down and put sugar on top, is this just on the frames of one box?
Yes,
Or
just on the top box. And you could probably just, a 10-pound bag is about the size of a football, right? So you could probably just easily, in fact, if it's a little bit lazy, but they're really good at handling paper, you could probably take a paper 10-pound bag and kind of put it in there. And I don't know if it would be too much space to put another box over the top of it, but you
yeah.
could just kind of dump that whole thing in there. What I do when I get out to the apiary and I've run out of newspaper is I just tear that paper off of the sugar bag, and
Uh-huh.
sometimes use that as the paper that I then put the sugar on, and the bees do really well with it.
Wow. Okay, that's way more sugar than I was thinking. I usually I I put sugar on top of the inner cover.
Mm-hmm.
Um and I've never put that much But I guess if you're checking once a month, you need to really put a lot on. So, okay, that
Yeah,
answers my
and
question.
the nice thing is nothing goes to waste. So let's say we put it on now and it turns into like a giant sugar cube, hard as a rock. And the bees have a ton of their own honey stored already, and they completely ignore the sugar. Well, in the spring, you just take it and you dump it into a bucket and you put hot water in it, and it's your 2-to-1 syrup for spring. So it's really ideally if you've got those 10 frames of honey
Uh-huh.
going into winter, then they should be fine without any kind of feeding. I just like to for just double measure, I just like to make sure that they've got enough. I've only ever in 8 years I've only ever had one colony starve to death, and it is the most heartbreaking thing because it's so preventable. So
Mm.
I just always feed them a lot.
Okay. And that was 100 pounds for how many hives?
15 hives.
15 hives. Wow. Okay.
Yeah.
Thanks very much.
Yeah, what is it? That's about 10 pounds a hive. So that's about right. That's what about 8 pounds a hive. And what I use is those deep inner covers from Man Lake, and those are really easy. It's like 2 inches deep, and it's got a hole in the middle of it for where you can put a jar feeder. And so
Mm-hmm.
I use those year round, and I just have that on top of the hive, and I just fill that inner cover full of dry sugar, and then I put in my pollen patty and or a piece of a pollen patty, and I started using. There's a new product out called Bee Bites, and I started using that just recently. And I don't have anything to say about it yet, except I'm using it. I don't know if it's effective. I have read some people who have experimented on half of their hives and found that they built up better. And it's got seaweed and probiotics in it.
Okay. Thank you very much.
Yeah. Kathy, you got your hand up. Hi, Kathy.
Hi, you don't get to see me because I'm sick.
Oh, I'm sorry.
I've got bronchitis, but I've got my voice back. So I just want to say I quit doing the mountain camp, putting it on newspaper because I found that more of the sugar wound up down on the bottom board and it attracted all sorts of other little pests and critters. So I put my sugar on top of the inner cover, no newspaper, just on top of the inner cover. And I have a shim on top of that, so there's plenty of room that the bees can
Yep.
crawl around on the sugar. And I also use a little spray bottle, and right around the hole, I spray that sugar with water, and it makes it easier for the bees to take it. And it seems like that it sort of cements in their mind that, hey, there's some sugar up here, let's go get some more. And by the time they've eaten the sugar that I had a little water on, there's condensation in the hive that they can use to liquefy that sugar real easily and make it easy to digest. So
Mhm.
I would recommend, if you haven't tried it, maybe do half and half and see what you think. But I had a lot less critters in the hive when I put it on top of the inner cover. And also, I don't like it if I need to look into the hive. It's like, how the heck do you pick up a newspaper that's been chewed and the sugar's dripping through and all of that?
Mhm.
It doesn't give me the opportunity to check my bees. So I've really gone 100% for putting sugar on the inner cover, and my bees always find it. They always eat it. I never have a problem with it being too far away from them. They will break cluster if they're right above the cluster to get the sugar because it's warm. Um, so I think it works pretty well that way, and I would just suggest that you guys try it, see what you think.
And what Kathy is describing is similar to what I use. It's just made out of things that you already have on hand. So she has an inner cover and an emery shim, which is about an inch high. And the inner cover, what they do is they come up through the hole on that inner cover, and then they walk around up there. And you open the lid and peek at them, and they are all over the sugar, eating it. But the nice thing is there's just a small hole, either that oval hole or a round hole. And what I find in the winter is the top of the cluster is right in that hole. So they basically don't let a bunch of heat go up into an empty space. They cap off that heat right there. But then when they want the sugar, they just walk up there and get it. And some people, there's a kind of I don't know if it's a wives' tale. I haven't experienced it very much. Where they say bees will throw the sugar out. If you put dry sugar in there too early, the bees will just think it's garbage and throw it out. I haven't experienced that, but what Kathy's tip about squirting it with water would kind of harden down the top of it so they couldn't carry out individual grains. Did you have something, William or Bill?
William, but it doesn't matter. I'll answer
Okay.
anything. Yeah, I think so. It's a quick backstory. I think I'm down to one hive. I lost a hive to sort of hopelessly queenless scenario and like crazy quantities of laying workers, and I finally just had to give up on that hive, and I'll start it again next year. But I have another hive that I think we're on our third queen. We started the season with the Carniolan queen that we had from last year, and we did an inspection maybe 8 weeks ago. It was in the summer, and we found a queen, but she was a golden yellow queen. She wasn't the glossy brown queen that was there before. So, like, yeah, they swarmed probably or something, even though it always felt like there were a gazillion bees in the hive, and I never really noticed a swarm, but that's probably what happened. And they were fine all summer, and then a couple weeks ago we were inspecting them, and there was a gigantic beard of bees on the bottom of one frame, and a split second too late, I saw that the queen was among them, and then they all fell down, like onto the ground.
Oh,
And
no.
yeah, and we couldn't find her, and it was chaos, and we were worried about stepping on her, and so we just sort of closed up as carefully as we could and came back the next week, and they had started to produce swarm cells or supersedure cells. And then the next week after that, they had hatched some of those cells. So we're pretty sure we're now on the third queen. I was worried that it was going to be too late in the season for her to go out and get mated. But last week I saw her, and she was a fat mated queen, and there weren't any larvae. But Sunday, I went in and there were larvae, and there were capped brood, normal capped brood, not like drones. There are no drones in the hive, which is really weird. I didn't see a single drone in the last month.
There's usually not this time of year. That's
It's
okay.
like,
They're throwing the drones out. So no drones
I'm
is no.
happy. Last year they left a bunch of them, and this year they're just like, no way. So my question really is, somehow I think they've gotten a little setback. The two brood chambers, there's some nectar in there, but there isn't a lot of capped honey. I have two almost completely full supers full of capped honey that I have not taken off yet. And so one question is, do I take one or both off? Do I leave them both for them in the summer? Is it better to leave them with sugar? I haven't added sugar yet. And then the next question is moisture management. Is it better just to add like a moisture board, or should I add the quilt box and the moisture board, or just a quilt box? I do have a quilt box I can put into action if I need to. And I live in Seattle, so.
Let's do the moisture board first, because that's
Yeah.
easier. I'm a fan of moisture boards. I like to use the boards, but if you've got a quilt box, you can use that. They both work just as well. You don't need to use both of them. Pick one. And I like the moisture boards because they're less fuss and less space to store. And then just a quick tip about the queen. If you ever drop your queen or a pile of bees in the grass, and you know, it's like trying to get gum out of a 5-year-old's hair. You know, they're not coming back out of that grass. Think of a waxed frame as a bee magnet. They don't like being out of the hive. They want to be on a frame. So all you have to do is put a frame kind of gently over the top of them or near them.
I see.
And especially even if it's kind of up at a slight angle, so they've got a spot there where they can cluster. In 10 minutes, they'll all be on it, and you can just pick them up. And
Okay. That's good to know. Thanks.
Yeah, so think of it like a magnet for nails, but it's for bees. Now for the food, it's not ideal to winter over with honey supers on, because we try and keep the honey supers, the wax nice and clean so the honey stays light. But if there's no other food and you have honey, then that is just fabulous for them. So in this case, I would definitely leave those honey supers on over winter. Do not use a queen excluder. Get those queen excluders out of there, because the bees won't leave the queen in the brood, and they'll starve to death. They won't go up into the honey if the queen stays down low.
So just be ready that those frames are going to be a little messy.
In the spring, they'll have brood in them. It'll turn a little brown. It's not the end of the world. And then in the spring, what you do, the first thing we do in the spring is we reverse our boxes, because the bees are all up in those top boxes. So they're going to be up there laying brood in your honey supers, which is fine. And the bottom boxes will be empty. So when you reverse your boxes, you'll get those honey supers on the bottom, and make sure, even if you have another box, that those honey supers are all the way down on the bottom, and the queen will move up and
Okay.
out of those honey supers. And then at that point, you can take them out of there. And if it
Okay.
doesn't look like she's actively, if she was kind of hanging on to those honey supers and she really likes them, what you can do is you can get the queen up in the box above and put a honey super. So you've got honey supers on the bottom that you're trying to get them to hatch the brood or emerge the brood out of. And then you've got your honey supers on the bottom, put a queen excluder on top of those honey supers, and then put your queen above that.
Okay.
So she can't lay down there.
So kind of upside down, sort of. Yeah.
Yeah, but that's how to kind of reclaim your honey
Yeah.
supers from the queen in
Okay.
the spring.
Okay. All right. Thanks.
Yep. Hey, Kathy.
Okay, as far as that goes, if you are reversing boxes in the fall and in the spring, never, 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 never split the brood. And I can't draw it here, but if you have bees that are at the very top of a box, and you have other bees that are also at the very top of a box, and you switch places with them, all the space in the middle is dead space. So I'm more of in favor of putting all the brood in a box and putting all the honey down below. This is in the spring. Now, in the fall, I move those honey supers, I move the honey out of that and put at least a couple on each side, positions 1 and 2, positions 9 and 10 in each box. So as the bees are hatching out, there's food right there for them. And also if you have pollen, a frame of pollen in every box, it will really help the bees to go further into the winter before they start needing all of that sugar. And you'll just find that the outcome in the spring is a lot better when they've had the food all around and they don't have to leave, like, for instance, 2 boxes down to go up to get into the sugar because you moved honey right next to them. And I wouldn't put 2 boxes of honey on and leave them over the bees, because that's a lot of very, very cold space. And the bees have to go through that. Hopefully they will go through that, but they don't like to break clusters. So I would probably take 1 box, throw it in the freezer, and then watch to see what happens with the box, the single box that you've left on top. And as you see that being eaten, thaw the other box that you put in the freezer and put that on. So they only have 1 box that they're dealing with.
Okay.
I would do it a little differently. In the winter, I would put both of them on there because I don't like to go into the box in the winter. I don't want to go in until it's spring. So I don't know how much sugar they have or have not eaten, or how much of their honey. I would just put them both on it all at once. And the honey is a heat sink. So as the heat goes up, it absorbs and holds the heat. It's kind of edible insulation. So additional honey in the hive helps them keep a little warmer.
Thank you both.
Mm-hmm. Brian, is there any questions in the room? Oh, running for the microphone.
Hi, everybody. I'm actually on Zoom this week.
Oh, you're on Zoom. Hi, Brian. Sorry.
I don't know who took care of the AV this week, but whoever it is, thank you.
Can you talk to me about wintertime oxalic acid dribble? When should I plan on doing that?
Question. So treatments in the winter, especially right around solstice, are the most effective treatments that you can do because there's very little brood present, and anything you do kind of pretty much kills all of the mites. So right around solstice is an ideal time. Now the challenge is oxalic acid dribble isn't recommended in winter, because basically what you're kind of doing is dousing the bees with water when it's under 50 degrees. And normally that's something that you would hold off doing until spring, when it's above 55 degrees, then you could do a dribble. If you want to use oxalic acid in the winter, either those extended release sponges work pretty well, or one of those, a vaporizer, either the wand or one that a vaporizer gun. And the vaporizer wands are not terribly expensive. They're like, you can get them for somewhere between $50 and $100. They are a little bit trickier to use, but if you only have a couple of hives, then it's a really great option to get oxalic acid vapor in the hive. But you have to remember when you're using vapor, and there's brood present, that you need to do it 3 times 4 days apart, except at solstice, because there's no brood. You can get away with doing just one of them. Was that helpful at all?
So I was thinking about the broodless period in winter, so you're saying that the vaporizer would be the way to go there as far as that. Or I'm in a single box, so putting the sponges on, they won't walk all over both sides of this.
That's okay. They don't, I think that Randy has said that part of the action of the extended release is, it's not a vaporization, but it's a fumigation. So it fumigates out a little bit. And they'll get enough activity on it. But again, remember, those are not actually a treatment. They're kind of more of a prevention. So if you really want to get a solid treatment in there in the winter, then the wands are great. We might have some to loan, or lots of people have them. You might be able to find one to borrow. They're pretty fun, pretty effective, and fun to use.
Dawn, can I make a comment to that?
Yeah.
Hi.
Hi.
So since I insulate my hives, I have found that even on warm days during the winter, when I peek in there, even around the solstice, mine tend to still have brood, even if it's just a little patch. So totally broodless is probably less common here in Washington than other places of the world.
Yep. And you're absolutely right. I completely agree with that. I do. I just went out and did my October treatments, and in theory it should be pretty low brood right now, but I'm going to do 2 of them. I don't think I need to do a full 3, but I am definitely going to do 2 in a row. So you could do 2 in the winter. The nice thing about oxalic acid is you really have to be trying to overdo it. There's I'm not going to tell you to do anything other than what is the recommended dosage and interval, but I have talked to people who, some people do it once a week all year long. Some people, I talked to one gal, she did it every 3 days for 3 months straight. And only at the end of 3 months did she start seeing some kind of problem with her bees. And what she was trying to do is, there's a theory of thought out there that you clean your mite boards and then you vaporize them and you look for your mite drop and you see if you have mites, and then you keep doing that after each vaporization. And the challenge is, there sometimes you never actually get to 0 mite drop. I mean, we always have some mites, even with any kind of treatment. And so this idea of trying to keep treating until you get 0 mite drop, don't worry, it doesn't have to be absolutely 0, just low. I mean, if you've got a package of bees has 10,000 bees in it, and so even if a few of those have mites, it's kind of not the end of the world. You can have a good number, a dozen or so mites dropping on your bottom board and still have a low overall mite count. Oh, and Toby's here. Hi, Toby. So do y'all, is anyone buying bees this year? Do you know where you're getting your bees from?
I'm hoping my hive survives and I can split it in the winter, but they're pretty good at making queens, apparently.
Yeah.
They've got a lot of practice this year.
Yeah.
I'm actually hoping to buy a couple of queens from Randy Oliver of his more or less mite resistant strains.
Yep. Yep. And it's kind of fun to try different queens from different places. So if you're doing a couple of splits, you might try different, just like the first advice is, do I get Italian or Carniolan? You know, get one of each. Oliveras sells Randy Oliver's bees, and they're located down in California, and they're a really big outfit, and they're really nice. They'll mail bees up to you. But in addition, Oliveras carries Northwest Carniolans and Saskatrazes. And I'm kind of a fan of the Saskatraz, but it's fun to get a variety of them. And the other one that we get up here sometimes is not Russians, the gray bee. I'll remember in a minute. One of our vendors, Dave Schiefelbein, brings bees up from California every year. And he brings up the other variety, which I'm forgetting the name of right now. If anybody remembers what the gray bee is, it's the other variety that's Caucasian. There we go. Caucasian bees. Yeah. So what are some things that anybody want to volunteer what you learned this year? That's the thing with beekeeping, is every year we make mistakes, we learn things, we do things right. What is something, what was one of your takeaways this year?
I left my bees alone more and they thrived better. I always get a little afraid during swarm season. But this time I didn't check on them as much, and in the end they just seemed to do better.
Yeah, and I've seen that a lot. I mess with my bees a lot, and I've seen that folks that leave their bees alone, they tend to grow a little bigger and thrive a little better, as like you said, as long as they're not swarming and they have enough food. Hey, Kathy, you can just jump in.
Well, I was going to say, please get in your hive every 7 to 9 days so that you know if you've got swarm cells. And if you don't really want to get into them, it's the second box that's going to have swarm cells down on the bottom, and you can just simply tip your box back, quickly look at the bottom of the frames to see if you can see any of those cells, and then you can react. If you do nothing, the chance that your hive could swarm and swarm and swarm again is amazing. One year I had a swarm into my neighbor's yard. I happened to see it. I went and got it. And but the first bunch that I was picking up to put into a box had a queen in it. And I thought, oh, great, I got the queen. She's a virgin, but I got the queen. And the next little handful that I picked up to put in the box had a queen. I wound up with 8 queens that had swarmed out. And I was scrambling for queen cages to make nukes out of all of them. But I really recommend that you get into your hives, because we don't want to have a lot of swarms issue that pisses off your neighbors, unless they just happen in your yard and you can pick them up. You're not really doing a service to the community. So, just keep an eye on that. And you can quickly check for them. So it's not like you have to do any big inspection. You can just lift that box up, take a look, and then respond as necessary.
And as you gain experience, it gets a little easier to kind of guess when your bees are thinking about swarming. Now they're always going to try and pull a fast one on you. So, checking once a week is like Kathy said, is really important in the swarm season. But the other thing you can do is you can do a preemptive split or just pull the queen out. One technique that some beekeepers do is they'll just pull the queen out with two or three frames of brood and some food into a nuke. So you basically build your own nuke. You want to make sure that there's eggs left in the original hive. And you put that queen in another part of the yard and they think they swarmed. And that queen, the box that's original, where the queen originally was, will make a new queen. And that's a really nice way to requeen your colonies. with, if you've got a queen that you particularly like with that stock. And it's kind of risk free for the most part, because if for some reason that queen doesn't get mated, you can just recombine those bees back together again. But in the meantime, if there's no queen in there, or you've got a virgin queen and she's out getting mated, they're not going to swarm. You want to check, of course, to make sure that they haven't made so many queen cells that they're going to do subsequent swarms. But if you go in there after you've taken the queen down and you knock it down to 2 or 3 cells max, maybe 2 cells, let's talk. Then you've kind of eliminated the chance for a month that they're going to swarm. And that's a really good technique to do if you're going on vacation too, and you're worried about them swarming around vacation. Just pull that queen out, let them make a new queen. You could do it, say, a week ahead of time, and that way you can check those queen cells that they're making and make sure they're not going, too hog wild with the queen cells. And then you can go on vacation for a few weeks and know that your bees are not going to swarm while you're gone.
The other plus with that is that when you have the box that you took the queen out of, there is a brood break, and that stops the mites building up. So it's kind of a great thing to do whether you need it or not, because you can always use a newspaper combination, put them back together again. And if you've never done a newspaper combination, what you want to do is evaluate your queens, and the one you like the best put on the bottom, and then you put the other queen and her box up on top, and heat rises, pheromones rise. The queen up on the top says, oh my gosh, there's another queen, I have to go kill her. And she goes down into the queen you want to have come out of it. And that queen's bees ball that queen and suffocate her, and you wind up with the queen that you wanted, not just any queen.
And one thing that's a little hard to get okay with when you're just starting out is the idea of replacing your queens when they still seem to be doing okay. Queens used to last 5 years. The pros now, they oftentimes requeen every year. I try and, except for my really, really top performing hives, I requeen them. If they're just kind of running low to medium, requeening them gives them a boost. If you requeen during blackberry flow or in the fall, your hives tend to survive better over winter because those queens are really vigorous. They have a lot of pheromones. And then also, it's a new queen in the spring, and so they build up really strongly in the spring. So pulling that nuke out, if you can, think that they're not going to swarm until just before blackberries or so, if you kind of do it midsummer to early fall, when there's lots of food around, that's when they make the highest quality queens. You have the best chance of getting them mated. And it's you can requeen your own apiary with queens that you've made from a split.
Also, when you have a new queen in the fall, she is very unlikely to swarm in that first year. So you save yourself from having to deal with a lot of swarms.
Yeah. Second year and on, the queens get swarmier. And the reason is because their pheromone level begins to drop. As they get older, they have less pheromones, and the lower amount of pheromones incites more swarming in the bees. So there's a lot of good, really natural ways to prevent swarming and get some benefits also.
Also, the main reason for swarming, besides the queen, is lack of space. And everybody thinks, oh, just throw a box on top and you're good. Put an empty frame in every box. If the bees have work to do, they will be working on that rather than thinking, oh, I better make a new queen. So just remember, space is not just a box on top. It's space in all the boxes.
Good. What else did you guys encounter this year?
How about the spring dearth?
That was terrible. Thank you, Kathy. I just want to remind everybody that if this is your first or your second year and you have bees, you're doing great. This was a really, really hard year for beekeepers, not just in the Pacific Northwest. In national, people in Italy, people in Slovenia are all just complaining about how there's less and less honey coming in. And this year in the Northwest, it was particularly bad because we hit a really weird dearth in June. So if you have bees, if you still have bees right now, you're doing really good. They didn't starve. You were watching. You fed them if needed, or they had enough food around.
And this year, I don't know if it had to do with the dearth or what, but I saw more super procedures than I've ever seen in one year.
And I have a theory on that. I think that as the natural food stopped coming in, not patties or syrup, but the natural forage stopped coming in, I noticed that the queens stopped laying as much. So not only were we losing the existing bees, but the queens kind of shut down their laying, reduced their laying quite a bit. And I think when they did that, the bees decided that the queen was failing. And I think we did get a lot of, I know William was talking about his queen being superseded. And I think that happened more than normal this year.
Yeah, and that hive was doing actually really well. I mean, they weren't as good as the other hive, but there were a bunch of bees and they survived through the winter really well. And I was very surprised when we ended up with a completely alien queen in the hive.
Yeah. They're always doing things that surprise you, so they keep you guessing.
They really are.
How about in the room? I see Kathleen. Hi, Kathleen. How's the apiary doing, Kathleen?
Good. We down there today, we checked, and they all bees are alive and well, and they have not really touched the sugar that we've got up for them. So so far so good.
Good. Fed them a lot in this late summer and early fall to kind of get them loaded up, huh? Yeah.
How many hives are there?
There's 4 Langstroth and 1 top mark. 5 total. Yeah.
Did you combine this?
We did.
Oh, we turned around.
Yeah. What do you? Hang on. Help.
I didn't do any combining because there were more when I was there.
Yes. We did. I we lost a clean one. So we did one.
Mm-hmm. Okay, so I think what I'm going to do is just cover, it's always my favorite part of club meetings is when we can kind of do a roundtable and ask questions. And our spouses get so tired of listening to us talk about bees that it's always nice to be in a room full of beekeepers. We can actually talk about bees. I think now we're going to move on to a little bit of club business. And then if it's okay with you, Abby, we'll jump into your talk a little bit on the early side. We're into October now. We're towards the end of the year. Next month is our business meeting. It's a business meeting and a potluck, and it's going to be right in the wisteria room where you are now. I think you're in the wisteria room. Yeah, I recognize it. And so we'll have a potluck there, and we will also do elections for the board members. So it's really it's one of my favorite meetings of the year. I think we might have also bring in some food. Last year we weren't allowed to do a potluck because it was still too close to COVID. So this year I think we're both bringing in some food and people will bring dishes. And watch the newsletter. The proposed board for the year will be there. If you're interested in being on the board, send me a note, and we can find a spot on the board for you, or we might, you might be on the slate for voting, or on the ballot to vote. Even if you're in remote on Zoom, we still have a way that you can vote. If we don't have any contested positions, it's just going to be a slate vote. It's either a thumbs up or a thumbs down on the list of people. If there are additional people that want to come on the board, then what we'll do is we'll give you a few minutes to talk about your experience, and you don't have to have any experience at all, but why you want to be on the board, and it really is a nice board. And then we'll just kind of, everybody does a vote. So it's a really fun and easy evening. Kind of kicks off the holiday season. What else? And so that is our, and then there's no meeting in December. So we'll have our November business meeting, and there's no meeting in December, and then we will start back up again in January. And I think in January is when we do our vendors. It's either January or February. Our vendors all come in and talk to us about, what kind of bees they offer, and that's always a really fun meeting. We get great presentations from all the vendors. They show you their bee yard and talk about their philosophy on raising bees. Did I miss anything? Magali, Kathy, Brian? Did I miss anything coming up? I don't think so.
All good, I think.
Okay, good. It's always a little hard to make sure I got it all.
Chat on yours, Tom?
Hmm?
Can you see the chat? There's been a couple questions on the chat.
Okay, so let's go through the thank you.
Yeah.
Oh, good. Somebody answered thank you, Magali. You answered Jeff does, somebody asked if anybody knows anything about long langs. Jeff does top bars, which are kind of similar to long langs. I actually have a long lang that I've run for a couple of years, and there's also one up at one of the clubs that I've run. So what I'm going to do is there's a little bit a different way, slightly different management techniques, not hugely different, but slightly different. Actually, there's two of them at the clubs. So what I'm doing is I'm putting my email address in the chat, and you know what? I'm just going to give you my text. Well, yeah, I'll give you my email, and then we can go to text. So you can feel free to send me questions. There we go. And I'm always answering questions, so don't ever feel bad about sending notes and questions. Oh, somebody said, what's a dearth? Thank you. We forget that we have brand new folks. A dearth is when there's no nectar flow. A dearth, think of a dearth as being an empty refrigerator or an empty cupboard. There's no food out there for the birds, for the bees. And it doesn't always look like a dearth. One of the biggest dearths that we get in the summer that surprises new folks is right after the dandelions are done, the buttercups bloom. And the dandelions have pretty good pollen and food for the bees, and the buttercups do not. So you see these fields of yellow, and you think, oh, there's a ton of food out there for the bees, but there's kind of nothing in a buttercup. In fact, buttercups are slightly toxic. And so what you have to do is you have to watch the mood of your bees. They get really cranky when they're hungry, and you have to look at your frames and see, is there nectar? Is there honey? Do they have pollen in the frames? Every time you go in, you're checking for food stores. During a dearth, we often have to supplement with syrup or pollen patties. So let's see here if there's, Toby answered that. Toby already got to it. Thank you, Toby. I'm chatting on, you already got it. Somebody had a question about the potluck. What's a good thing to bring? I think anything you like to bring that you like to eat, other people will enjoy also. We've had really good salads and pasta dishes and desserts. So whatever you like is good. And James is asking if there's any assistance needed in the apiary. Let's see. How do I hook James up with Kathleen? Let's see. I don't have your email here, Kathleen. I don't know. Kathleen, are you going to need help in the apiary over the winter, or would you like to take James's name for the spring?
Oh, we had a cleanup day that I had to cancel. I'm going to put a new one on the calendar. I'm hoping for the first week in November. So James, if you just take a look at the event calendar on our website. You can come on out and then we can connect.
And I think Kathleen, isn't our contact information on the website for the board members?
Yes.
Okay, so James, what you want to do is you want to look up Kathleen. I'm going to say this wrong. DeVilbilis? Did I say that right? Vilbus, okay. You want to look up Kathleen on the website and send her a note. And I know during the spring and summer, we do need help. We need people to come out. And so that Kathleen's not coming over from Bellevue all the time. We need folks who can feed the bees or mow the lawn or do a mite treatment. Just kind of those really basic things. It's not something that you would need to know the schedule. She would tell you when to do it. But for her to not have to drive over and do it herself sometimes is amazing. Oh, and there's the calendar. So, oh, Kataria. Hi, Kataria. There you are. Yay. So I think with that, unless anybody has something else, then we will turn it over to Abby.
Hi, John. I
Yes.
have a thought, which is just a reminder of what date the November meeting is, because it's a week earlier than normal.
Right.
It's 9 days before Thanksgiving.
Okay, and what day is that? I don't have my calendar open.
19.
The 19th?
Yes.
Okay, I have it in my notes somewhere. So it's November 19th. And that will also be in the newsletter. And I think that what we'll do is, Cass is our amazing newsletter person. I think what we'll have her do is even put that in the subject line. Potluck, business meeting, November 19th. So folks know that it's on a different day. Thank you, Bruce. Anything else? No? Okay. Well, let's thank Abby. Hi, Abby. So we're really looking forward to your talk, and tell us a little bit who you are, and we're excited to hear from you.
Yeah, great. I have a slide for that. So I'm first going to see if I can share my screen before we get going here to make sure. That should, let's see. Can you guys see my screen the way
Yep.
it should?
Yep, in full presentation mode. Yep.
Perfect. Great. So I'm going to talk about Queens today. And yeah, my name's Abigail. I'm a PhD candidate, very close to the end weeks from the end here up at the University of British Columbia. And I've worked really closely with Dr. Alison McAfee, who some people may have read. She's written a lot of things for the American Bee Journal and a few things in Scientific American. And Leonard Foster is a lot of bee research has come out of his lab in the last decade from UBC there. So a little bit about me. I got my bachelor's degree in biochemistry actually from UBC back in 2019. And as I said, I'm very close to finishing up my PhD now. I have been beekeeping since 2017. I started during my undergrad degree, I got involved in Leonard's lab, and that was my introduction to the world of bees, really, and have just totally fallen in love with them since. And I have gotten to help a lot with managing some of the colonies we have at the university, as well as working pretty closely with a few mentors that I've been really lucky to work with of commercial beekeepers. And I've worked really closely with Dr. McAfee. She actually graduated from her PhD at the same time that I got my bachelor's, which was pretty special. And I am transitioning once I've graduated to actually become a full-time queen producer. I really want to work in the industry. And that's with Emily Huckster. She's in the Okanagan region, which is about 5 or 6 hours east of Vancouver, a little bit more interior. So queens, I love queens. My whole project has been focused on queens. I want to go into queen production. They are just such the interesting part of the hive. You're so excited to see them. They're mysterious and amazing. And so the first part of my talk, I'm going to talk about some of the really cool, interesting biology related to queens and their reproductive systems. And then at the end, I'll talk a little bit about some of the most exciting findings from the last 5 years of my PhD research. So just to get us all on the same page with what's going on in the reproductive system. So this is the inside of the abdomen of a queen. And the first thing we notice is that these two ovaries take up the majority of the space in her abdomen. The queen's abdomen is so big, mostly because of her ovaries. Her ovaries are made up of these ovarioles that we'll talk more in a second, but these long sort of chains. And she has about 200 of those in each of her ovaries. And then the other things going on related to the reproductive system here is the oviduct, where the eggs pass through, and then the spermatheca. So queens mate once or go on a couple mating flights in the first few weeks of their life early on, and they mate in mid-air, as most of us probably know, which is pretty wild. And they'll mate with many drones, 5, 10, up to 30 or 40 even, and store that sperm for the rest of their life in this spermatheca organ. And the bursa copulatrix is this organ that receives the sperm. And interestingly, only about 3 to 5% of the sperm that she receives during mating actually migrates into the spermatheca to be stored for her life. And so, yeah, it's a little interesting compared to us mammals. Human females are born with all of the eggs they will ever have, and then the sperm is like a one-time thing, and it's reversed for them. They are constantly producing new eggs in these ovaries, and they mate once and store that sperm forever, which is kind of interesting that it's a little bit reversed there. So the ovaries, the egg-laying factories of those abdomens. The mass of a queen's ovaries can be up to 40 to 50% of her total body weight, which is just remarkable when we think about the size of mammals' ovaries, our ovaries. 50% of her body weight is her ovaries. And with that, she can lay over 2,000 eggs a day if she's really going, which is roughly equivalent to her own body weight, which is just wild to think that she is able to take all of that energy and nutrition and turn it into eggs that quickly, her own body weight every day. And so that adds up to, if she's pretty long lived, over 1 million eggs over her entire lifetime, all of which makes honeybee queens. They have one of the highest levels of fecundity among any insect. Fecundity is sort of synonymous with fertility, the ability to produce a lot of offspring. And as I pointed out in those two ovaries are made up of ovarioles, which are sort of like these conveyor belts that the eggs develop in. And so a queen has about 200 in each of her ovaries. The number of ovarioles in an ovary can vary hugely between insects. Some insects might only have 1 or 2. Some beetles have 1,000. But a queen has, on average, about 200. And this is interestingly one of the main distinguishing things between queens and workers. So workers actually also have ovaries, they're females, but most of the time, we hope they are not laying eggs. And a worker has actually only 4 to 10 ovarioles in each of her ovaries, so they're much, much smaller, not so specialized for laying eggs. And through these conveyor belts, the developing eggs, which we call oocytes, move through and along the conveyor belt as they mature. I realized I'm motioning at the screen without the laser pointer. And so they start at this end, the terminal filament, the stem cells where they're dividing. And then we start to see them be interspersed with these dark blobs called nurse cells that are sort of accompanying the white oocytes as they're moving along these conveyor belts and just dumping tons of nutrition and resources into these eggs so that they can develop in the vitellarium. This is where a lot of vitellogenin is a protein that some of us might have heard of, and that is the main egg yolk protein that will be used for nutrition as the little embryo develops once it's been laid. And then it nears the end as it's getting closer towards being laid, and right at the end, this egg shell is deposited along the outside that helps prevent water loss but allow for the exchange of gas so metabolism can happen. And then it's laid. And if it is fertilized by sperm, it develops into a female worker or could become a queen. If it's not fertilized, it develops into a drone. So these are some actual pictures. This is a picture I took through a microscope, and this is actually a bumblebee ovary. So this is quite a bit larger than a honeybee ovary, but it's really cool because almost with the naked eye, you can actually see the developing eggs interspersed with the little nurse cell hairs. And bumblebees only have 4 ovarials per ovary, which makes it quite a bit easier to see what's going on. But it's just really cool to actually be able to see with the naked eye what those diagrams look like, and see here at the end are these big full eggs that are pretty close to being laid. This bottom picture is not one of my own photos, but this shows a honeybee queen's ovary under a microscope, and these are worker ovaries. So quite a bit more spindly, but the same overall structure of a few of those ovarioles. So with these amazing ovaries, queens exhibit a huge amount of plasticity. And by plasticity, I mean the ability of an organism to change its behavior, morphology, physiology, something about it in response to the environment. So the ability to change. And so queens are pumping out huge amounts of eggs, 2,000 a day, but they aren't just doing that all the time. They can periodically stop laying when they need to. So that will happen before swarming, so that their ovaries can shrink up a little bit so they can actually fly. During the winter in colder places, they'll go through a broodless period where they're not really laying. Or if we cage a queen, she doesn't have anywhere to lay, so she can turn off that production somehow. So what is the cues that allows them to realize that they need to stop laying eggs or slow down their eggs? And there is likely quite a lot of things, but the major one that a lot of research has pointed to is nutrition, the availability of nutrition. But if we think about a queen, she's not feeding herself from the stores. She's being fed by the attendants around her. And so the nutrition she's receiving is really controlled by the workers in the colony. So it's kind of more of a democratic process, the amount of food that she's receiving from workers. She's not deciding how much food she gets. And so this has been shown over the years in different ways, in different circumstances. So for instance, the queen receives less food in the period leading up towards swarming. This was back in the 1960s. They saw that there was fewer workers around the queen and feeding her for shorter periods of time. So she's receiving less nutrition, and that is triggering her ovaries to kind of cool it on the egg production. More recently, in an experiment in a cage, the quality of the pollen diet fed to the workers directly affected the number of eggs laid by the queen. So in cages where the workers had a better pollen diet with more protein, those queens were able to lay more eggs. So the nutrition available to the workers that was then directed towards the queen in the form of royal jelly affected her reproduction. And in that final circumstance before winter, there's been some research that shows, in addition to some other cues like the shorter days, perhaps dwindling pollen resources in the environment, so less pollen coming into a colony, is one of the main cues that triggers the transition to this broodless winter population for bees, which is quite interesting. And so the paper that concludes this also has sort of interestingly found that feeding pollen much later into the fall when there's no pollen in the environment just kind of extends the period that sort of the summer bees are developing. And finally, once they stop having pollen coming in, then those fatty winter bees are being raised. So if nutrition controls it, how exactly are the ovaries doing it? What's going on in there? And what's really cool is that the ovaries never fully turn off. It's not like the whole process just totally shuts down. Instead, there's a series of checkpoints for regulated cell death. So essentially, if the conditions aren't right, sort of the conveyor belts are still going, but at a series of very specific defined points as the eggs are developing here, they will essentially die and get reabsorbed. And so that's really cool because it allows for this balance between the flexibility to rapidly start or stop laying without wasting resources. If the process is still sort of going, it's not totally stopped. It means that within hours or a few days, depending how long it's been, they can start laying again quickly if we take them out of the cage, for instance. but they're not just wasting a ton of resources producing 2,000 eggs a day that they can't do anything with. And the other interesting thing is that this sort of checkpoint situation is also actually happening in worker ovaries, just in the very, very early stages. So the workers are also pretty primed and ready to start laying, but obviously it takes them a few weeks at least to get going. And so this is just a cool study that came out a couple years ago, not from my lab, but I just think it's really interesting and cool to talk about. And so the effects of caging on a queen, this circumstance where we as beekeepers induce the queens to, or prevent them from being able to lay. So what they did is they compared the ovaries of queens that had been caged and then put back inside a colony. So it's just the colony is still taking care of them, or outside of a colony, the way that we might ship queens with just a few attendants. And then they looked at these ovaries using fluorescent microscopy, which is really cool. And that's what these images look like, where different parts of the cell are stained with different fluorescent dyes. So you can really see what's going on in there. And they looked at these ovaries at 3 different time points after they had been caged, 4, 7, and 10 days. And they found that this process of oogenesis, of the developing eggs, was more severely disrupted in the queens that had been caged outside of the colony. And while this could be due to other colony factors like the humidity or presence of pheromones and things, the authors suggest that one of the main factors is likely the quality of nutrition. A colony is certainly, a full colony with all its resources and many bees is certainly able to provide better quality nutrition in the form of the jelly to the queen than just a few attendants in a cage. So the sort of beekeeper takeaway of this study is that caging in a colony is definitely preferred. If we have queens that we're holding on for more than a few days, putting them in a queen bank will help them be better taken care of. Minimizing the time that they're in cages is very helpful. And potentially, although no one has looked at this specifically, one might be able to infer that perhaps including pollen as a source of fat and protein to the attendants while we're shipping queens might be able to help those queens' ovaries be in a better state to start laying more quickly when they are introduced to a new colony. So that's some of the cool, interesting stuff just about what's going on inside of queens and why they're such fantastic reproductive machines. But what we really care about, beekeepers, is whether a queen is doing her job in a colony and whether she's a good or a bad queen. And so this is getting closer towards my research about what makes a queen bad. And poor queens are a really big problem. They are always among the top few reported causes of colony loss, both in Canada and in the US. And there's some evidence that they are being replaced at very high rates compared to historic norms, with, some large commercial operations replacing queens every year even. But this whole concept of poor queens or bad queens is actually somewhat challenging to define. There is a handful of symptoms that I have used with my project that most beekeepers would probably use some combination of these. And that is sort of this just low brood production, stunted colony growth, low population. She's just not laying enough. She's a drone layer, so she is inappropriately laying unfertilized eggs in worker cells. She's doesn't have enough sperm left, or it's dead, or something like that. Early supersedure, we might not know what the problem with this queen is, but the bees don't like her for some reason. Or poor laying pattern is one that frequently gets tossed around as to what makes a queen bad. But ultimately, it's often, and even this is from a paper that was published, just this overall gestalt or feeling that a beekeeper gets about whether this is a good or a bad queen. But interestingly, some of these symptoms of poor queens might not actually be the queen's fault. So for instance, poor laying pattern could be the queen's fault because she is laying eggs that are dying. They have poor viability. But for instance, just one example is So it could be her fault as well. There's this thing called shot brood, which is this sort of built-in control for genetic diversity. So if a queen has mated with a drone that is too closely related for her, and she fertilizes an egg with sperm that is from somebody that's too closely related, those eggs smell bad. Essentially, the workers can sense them and they eat them. And so often this shot brood pattern where it's like really, really spotty brood, it could be because of that. So that kind of would be a queen problem. But for instance, things like brood disease can really cause spotty brood. And we see this especially in the spring when there's chalk brood problems, where there's a poor pattern. And even once the disease has been cleaned up, just the fact that it started with a poor pattern means that she's coming back and laying in the holes and the pattern just kind of stays crappy. And if we put a second box on and she moves up into fresh comb, maybe the pattern's fine then. But sometimes we might misdiagnose that. And interestingly, in a recent study, they switched queens that had been identified as poor pattern queens into good pattern colonies, colonies that the queens were laying and had nice patterns. And putting poor queens in good pattern colonies improved their pattern, which doesn't explain why that's happening, but does just illustrate that there's lots of factors going into the colony environment and what's going on that lead to patterns. So that's probably not our silver bullet for defining a good or a bad queen. But sometimes, as with the case of shot brood or other things, it actually is the queen's fault. She is a bad queen. It's not colony circumstances. So what can cause that? One is rearing conditions. We know, for instance, if we, as beekeepers, are creating queens, if we graft eggs that are a little bit older, those queens will be more similar to workers. They'll have fewer ovarioles and be smaller. Poor mating, if a queen had poor mating weather and she just isn't well mated, she doesn't have enough sperm to last her life, she might become a drone layer where she starts to run out of sperm to lay fertilized eggs to become workers. Or the sperm that she has enough of it, but it becomes damaged. And we know that temperature is one thing that can do this. Allie, who I have worked with, was looking at the shipping conditions of queens, and in shipping, if queens are exposed to really high or low temperatures, that can damage the viability of their stored sperm. So she might be trying to fertilize eggs, but with sperm that's dead. We also know that pesticide and the buildup of acaricides that we're using against mites in our colony, exposure to that can cause problems for queens for their reproductive physiology. It can increase their mortality. It can suppress their immune systems. But what I was interested in looking at, which was kind of a gap in the field here to figure out what makes a bad queen, is infection a factor, is what I was curious about. So infections in queens, we don't know that much about actually. If we think about most of the pathogens, they're usually identified and studied in workers or worker brood. So if we think about sac brood virus, the fowl broods, that's all in worker brood. Even deformed wing virus, we see that almost always, if that is symptomatic, in workers. But despite the fact that most of these pathogens don't have symptoms that we see in queens very frequently, almost all of them have been detected in queens. It's just sort of asymptomatic. So I was curious if, even though we're not seeing symptoms, could this be causing problems with their health? And this was further interesting to me more from just an interesting biological point of view, because of this phenomenon that is a reproduction immunity trade-off. And so we see this in a lot of organisms, tons of insects, even mammals, where reproduction and immune activation are both really intense processes. They require a lot of resources to either make babies or produce eggs or to activate the immune system. And so often there's this compromise between them. So we'll see that reproductive individuals that are, insects that are actively laying eggs might have suppressed immune systems, or the opposite end of that is insects or other organisms that have their immune systems activated that are fighting an infection will reduce their reproductive output. And so I was curious if infection could reduce queen success even in the absence of like direct pathogenic effects. So by that, I mean that there's a potential that even if the virus isn't making the queen sick, it could be reducing the amount of eggs that she can lay. So getting into my research, this sort of all started back with beekeepers. Back in 2019, the Bee Breeders Association started this queen survey with Allie, who I work with, and they wanted to look and see the quality of local BC produced queens. So we looked at ovary mass and the viability of the sperm that they still had stored, the total number of sperm that was stored. And brilliantly, Allie also requested that they send along some failed queens as well, so we could compare these. And sperm viability had already been linked to queen failure previously, so people had found that queens that were failing had reduced sperm viability. And so with these bad queens that we received, we looked at viral analysis. I was curious to see if infection was a factor here in failure. So we sent the heads away for virus analysis. We measured the mass of their ovaries. We looked at the sperm viability using a similar technique using fluorescent microscopy where the dead sperm gets stained red, the live sperm are stained green, and you look and see how many of her sperm are remaining alive. And from this initial survey where we looked at these factors, the main outcomes of that were that the failing queens, the queens that beekeepers thought were bad for some combination of those symptoms we were just talking about, those failed queens have reduced sperm viability and smaller ovaries, which is not groundbreaking. We would expect that. Beekeepers think they're bad queens because they're somehow not, their reproductive output isn't great. It makes sense that their sperm viability is either poor or their ovaries are smaller because they're not laying as many eggs. But it was really nice to be able to actually quantify that and say, this is a queen that a beekeeper thinks is bad, and there's things that we can measure and actually relate to that. And interestingly, we also found that those failed queens have higher viral loads, which was interesting. So my hunch, my hypothesis that perhaps an infection was one factor here, we were onto something. And we also found that regardless of whether the beekeeper thought the queen was healthy or failed, queens with higher viral loads had smaller ovaries overall. So that was interesting to start. But the question now was, is this causal or correlative? We don't know if the infection is actually causing the smaller ovaries or causing the failure, or if they're just correlated for some other reason. Maybe they're just bad queens and that makes them more susceptible to virus and there isn't this cause here. And so I wanted to see, does virus infection actually cause these things? So to do that, I spent several years, the last 3 years or so in my project, doing experimental infections to try to tease out these things. So I was doing that with this setup here where I have a microscope. This is what a queen looks like to my eye through the microscope there. And this is a micro injector setup, and I can inject them with virus using this teeny tiny little needle that I made from a pulled glass capillary. And it's so fine at the tip, you really can't even see it with the naked eye. And I anesthetize the queens with CO2 for a few minutes, which puts them to sleep. And then I can slide that tiny little needle in between the plates of their abdomen and inject them with an incredibly tiny little drop of liquid containing virus to start to tease this apart. So the first few experiments we did, I started with Israeli acute paralysis virus, which we just already had in the lab, and kept the queens just in a cage in an incubator with a few attendants for just 3 days. And we found that the queens that had higher levels of virus, which is along this x-axis, had smaller ovaries. These are color-coded by the queens that received the virus itself or mock, like a saline control injection. And unfortunately, the mock injected queens still had some level of virus, which is why this is shown as a continuous relationship and not just a bar graph showing the difference between the groups. But it was enough to see a trend that there is a relationship here. So next I tried with a different virus to see if that would have similar results. So I used cricket paralysis virus, which is not, as the name would suggest, a virus that naturally infects bees, but is in the same family as black queen cell virus. And this was a little bit longer in the incubator, and I found that the higher dose that I used, the smaller their ovaries were compared to the queens that received a saline injection. So starting to see a trend here. But I wanted to look at a more relevant virus. Israeli acute paralysis virus is pretty common, but is also a rather symptomatic, intense virus when it's even in still pretty small doses, particularly in workers. It really causes obvious symptoms pretty quickly where you get the trembling, the paralysis. And so I wanted to look at something that is really more commonly like ubiquitously spread in the population. To try to find something that's a little maybe more relevant. And also there's this sort of so what feeling about just looking at the ovary mass. Like as beekeepers, we don't really care about the mass of the ovaries. We care about her output, the eggs that she's laying. And also I mentioned back at the beginning, part of what makes this interesting is this potential trade-off between the reproductive output and immunity. So how can we look at that factor? So the final experiment I did used a combination of black queen cell virus and deformed wing virus, and these are really common, detected in upwards of 90% of samples, particularly deformed wing virus globally. And we have found them in multiple queen surveys to be in almost all of the queens we test in some level. So this is very field relevant. Many or most of our queens have infection levels of some kind of these two viruses. So I first started with these two, a combination of these two in the lab in these really cool egg laying cages where I can have a queen that actually allows her to lay eggs in the incubator. And this was for 2 weeks. I had 10 queens in each group. I had a control group with just saline, a group with this virus infectious, a combination of these two. And then I also included an inactivated virus group. So this is almost sort of like a vaccine in that this virus has been killed by UV exposure, so it cannot infect the queen or make her sick in that way, but it should still trigger her immune response to those viruses. So this is how I want to start digging into this trade-off part. This is a picture of these cages that I used. We received them from another lab and they're super cool. They have these injection molded plates with comb in them in plastic that are removable. So I have the queen with about 100 attendants in there and can remove plates to collect eggs and count the number of eggs that she's laying each day, which is a cool system to be able to look at things a little bit more closely in the lab. And so what I found from this was, again, this same trend, which is nice to have consistency, that there were smaller ovaries. This is the infected group compared to the group that received saline. Clearly, their ovaries were smaller. And interestingly, there's some initial evidence that there might be a trade-off occurring here between immune activation and reproduction. So the group that received the inactivated virus had somewhat smaller ovaries than the control group. So this isn't being caused by some effect of the virus. The virus can actually make them sick, but something about just their immune response to that is maybe responsible for this reduction in ovary mass. So that was exciting to see some initial evidence for that. And we also, because they were in these fancy cages that I could track egg laying, was able to look at that. So just a little further beyond the ovaries. So in this left one here, I am saying, did the queen restart laying eggs after injection? So the queens were in those cages for a few days injected and then in there for another week. And they all were laying before they were injected. And 8 out of 9 of the control queens did start laying again after injection. 7 of the inactivated queens did start laying, but most of the infected queens did not start laying again. The queens that had been injected with that live virus just didn't start laying eggs again after they've been injected at all. And then here on the right, we see that regardless of the group, the different colors or groups, each dot is a queen. The more total virus she had at the end, the fewer eggs she was laying per day at the end. So this is able to say that it's not just the ovaries that are smaller. We can actually start to tie this to some measures that we do care about, which is the eggs that the queen is laying. So then we finished this up by using the same virus combination, but actually taking it to the field, which is what we really care about, field conditions. So same dose of virus, but this time we followed the queens for 6 weeks after they'd been injected. The queens were put in nukes. We had 16 colonies in each group, and only the control and the live virus groups in this experiment. And interestingly, there actually wasn't a difference between these two groups in ovary mass. Between the group that was saline injected or the virus, their ovary masses were pretty much the same at the end of the experiment, 6 weeks later. But if we delved into this more closely and just look, rather than the group that they were in, just looked at the total amount of virus they had at the end of the experiment, there is the same trend that we've seen the whole time, where they have smaller ovaries with greater amounts of virus, which is not a surprise, but is interesting that we have injected the blue dot queens, the infected queens, with virus, but over the course of 6 weeks, it seems to be the environment they are in the colony has impacted the amount of virus they have more than just the injection I gave them at the beginning. But was really most interesting little tidbit to come out of the field trial part of this is the total amount of virus correlated with the presence of supersedure cells. So a handful of these colonies had supersedure cells, and we were blinded. We didn't know which colony was in which group. But as the total amount of virus increased, the likelihood of us finding supersedure cells in those colonies increased as well, which is just really sort of initial evidence for the correlation of that, but is intriguing because that is sort of potentially one other connection of this other symptom of queen failure, supersedure, that is associated potentially with levels of virus infection in those queens. So what does all of this mean? With my research, the same pattern that we're seeing, smaller ovaries with higher levels of virus, and seeing this pattern with multiple different viruses in different settings, both in the lab and in the field and at different time points, is really good evidence that this is a real general effect of virus infection and not just the effect of one specific virus. We're not seeing that this is just like DWV doesn't just cause this. It seems to be that most of the viruses, to some extent in different settings, are associated with this reduction in ovary mass. And I also was able to collect some initial evidence that this is more meaningful than just the smaller ovaries, which who cares about how big their ovaries are in there? We care about their egg laying, and we're actually able to make some connection between that meaningful measure of reproductive output to just ovary size. And that final point, that the effects of this experimental infection were lessened when they were put back in this whole colony setting in this field trial. And maybe that is in part related to the better nutrition. Surely the whole colony, the little nuke, is much better able to feed their queen than just those 100 attendants stuck in a cage with her. So as a tie back to the beginning and the importance of nutrition. And then some more of the take-home points just of interest. The honeybees and in general social insect queens, so this is also true for termites and ants, are among the most specialized for reproduction in the entire animal kingdom, and that is illustrated by the fact that they can lay their body weight in eggs every day, which is astounding. And those eggs develop in this conveyor belt-like fashion within those ovarioles. And nutrition is one of the major regulating cues for the control of that process. And failing queens have measurably smaller ovaries and reduced sperm viability, and also often have higher loads of virus. And then some of the maybe slightly more practical take-home points that good nutrition, especially protein, which comes from pollen, is incredibly important for queen ovary function and brood production in general. It's important for a queen to lay eggs. It's important for workers to feed that brood. The symptoms surrounding queen failure are quite opaque. It's not always the queen's fault. Sometimes it is, sometimes it isn't. Sometimes it's good to pinch and replace a queen, but maybe not always. And then the question I always get asked when talking about my research is, okay, so if virus is, influencing queen failure, like what do we do about that? How do we actually put this information to use? And currently, the best way to deal with the potential effects of viruses on queen health are the things that we pretty much should already be focusing on. In particular, reducing mite loads. Mites are one of the main vectors of viruses in colonies, and quarantining sick colonies to prevent the spread of disease. If you have one really sick colony in your apiary, don't just leave it sitting there next to healthy colonies. Likely that infection will spread. And thank you so much for listening and inviting me. I love giving talks and talking to beekeepers. It's a shame that I can't be there in person. And a huge thanks to Ali, who has collaborated with me on pretty much all of my projects, my supervisor, Leonard, and some of my bee mentors, and these sources of funding. So yeah, thanks. And I love to take any questions.
Oh my gosh, that was so interesting, Abby. Thank you. I'm really interested in like the queen science and the viruses too. So that was a lot of really good information. I've got a question, but we're gonna get to some of the other folks' questions first. So Toby asked, can diseases be passed from the queen to her progeny in the egg?
Excellent question. Yes, particularly viruses. There is some pretty robust evidence specifically for sac brood virus and deformed wing virus that infected queens can pass that on to eggs. Still, some of them, it seems like the virus hangs on to the outside of that eggshell. Some of it is infected on the inside. But yes, certainly with viruses, there's not evidence so far for the spread of bacterial disease in that manner, which makes sense. Bacteria are quite a bit larger and have probably a harder time hiding away on an egg to get past that way. But that is an excellent question.
I was kind of on the same note. I was kind of curious when you were talking that the effect was not as strong in the field colonies, and I'm wondering if that was related to the social immunity. Is it possible that some of those bees were able to break down the viruses and then inoculate everybody? Or
yeah, there's so many factors in a colony. So potentially, like in terms of if she is laying infected eggs, those workers might be able to sense infected eggs and remove them. So we might have less of, it might be harder to detect some effects at colony level because workers are dealing with it that way. As for the effect of virus on the queens themselves, like the fact that their ovaries seemed to have recovered, could potentially be that the queens are getting fed better, and that's allowing their immune systems to, they have more resources to activate that immune system. But you touched on a point there about sort of the spread of immunity in a colony, and there is some really cool evidence, not so much yet for viruses, people are still looking at, but for bacterial diseases, that bees can transfer this form of immunity between each other and between each other to the queen and from the queen to her offspring. So this is the foundation behind that new AFB vaccine for queens that has come out, where we have been able to figure out that little fragments of bacteria can be transported all those pathways to help prime their immune systems to be able to fight back against that, which is really cool.
Very cool. Thank you. And Kataria asks, why do you think the reproductive system evolved to be so different in insects and mammals?
Yeah, that's a good question. I guess asking why something evolved is tricky. But the movement towards sociality, specifically in social insects, is really cool because it is so unique and it allows for this, what we call productive division of reproductive labor. And so it's, I guess, easier to say, how did that happen? And we can see that if we view these social insects as kind of a super organism, that the individuals are sort of acting like different cells that make up a whole body, a whole organism like us. And there's one part of that that is focused on reproduction. But exactly why, like where along the way was it advantageous for them to move towards sociality and a different type of reproduction? Oh, I guess you would have to talk to an evolutionary biologist.
I'm sorry, I'm not intentionally asking all these questions. We have a couple members who don't have audio today, so they're sending.
Oh no, that's
do you have chat? Do you want to open the chat and see if you can see the
sure.
questions directly?
Yeah, I will certainly. Let's see.
Maybe you can read it out and answer. Then
Yeah.
might
So a follow-up on passing diseases from queen to progeny. But does priming their immune system perhaps begin to stimulate that immune response that compromises fecundity? Excellent, Toby. Very sharp. Yes, so that is my concern, is this idea of vaccines is really exciting, but certainly with what I'm finding, there could be some unintended consequences to that. And obviously, we don't want to even ourselves walk around with an elevated immune system all that time. That compromises everything else we're doing. So yeah, maybe there could be ill effects. And if we are priming queens and colonies against an infection that they're not actually encountering or isn't going to be problematic, we might be just inviting a host of negative effects of that. The other interesting sort of concern I have about just thinking about this priming and this idea of vaccines is that transfer of bacterial fragments that allows that sort of priming response surely has a temporal end date. Like there is a limited amount of bacterial fragments in those queens to get transferred to their progeny. It's not going to last their entire lifetime, and we don't have any data yet on how long that does last. So definitely still some questions, but it is really cool and exciting to see some exploration into this idea of vaccines as a way to actually try to directly deal with infection in our colonies rather than just trying to reduce mite loads.
Is there any questions in the room?
I have one. Along with you talked about nutrition on transporting queens. Have you ever heard of anybody trying to mix pollen into the sugar plug that is
Yes.
the queen cake?
I would recommend not mixing it if you do want to experiment with this. Emily and I have tried this when we were shipping queens this summer, not in any sort of controlled experiment whatsoever. So I don't think it could hurt, but I would say it potentially could hurt if you're mixing it because you want the bees to be able to choose the nutrition that they want to receive, and potentially eating pollen or protein is harder for them to digest. So if we don't know, actually, since we haven't done any experiments, if they would like to have access to protein in transport, and we don't want to force them to be eating that to have access to the carbohydrates and sugar if they don't want it. I don't think anyone has yet published anything looking specifically at like optimizing those conditions yet, but it's a really interesting question.
I have a question about pollen that I've been trying to think about and figure out. So amongst the commercial beekeepers, there's this belief that when you give pollen patties, then that gets them to brood up. And that's primarily for getting them ready for almonds in February and things like that. But in the north, most of what we give the bees in the winter is the brewer's yeast. It's that fake pollen patty that's got like 5 to 15% real pollen in it. And I question this myths. You often hear the old timers saying, "Oh, don't give them pollen in the winter; they'll brood up, and you'll have a mess on your hands." And to me, I think that there's so many factors that go into brooding up. There's day length, there's temperature, there's the availability of natural pollen. That does giving them a pollen patty in the winter really have as much of a stimulating effect as dandelion pollen in the spring, do you think?
Getting into the decisions about pollen feeding can be very controversial. I've discovered going to
Oh, yeah.
different bee clubs. People have really strong opinions. I would say from both my experience working in bee operations and reading about the effects of pollen supplementation generally is feeding pollen is mainly advantageous when there is beginning to be some environmental pollen available. So feeding pollen when it is totally out of season and there is none available in your environment is likely not going to be super helpful. So that is the case early in the spring when it's really early and they aren't going to be able to go out on cleansing flights and there isn't any in the environment yet. And the same as well in fall when there's no pollen left in the environment and you're still feeding them pollen is probably not going to help them with their natural rhythms there. But I do think that there is a really significant effect, particularly in the spring, when you are right on the edge of there being pollen in the environment shortly. But it is really energetically taxing for them to go out, especially in those cold early spring days, dealing with wind and rain or whatever else it is to get that resource. And that is the cue that they're waiting for, is the availability of protein to be able to start brooding. So I do think that it is really helpful. And for instance, the operation I work in, we do a lot of nuke production, and I do think it is huge giving them that resource. The question of actual pollen versus the protein substitute is yeah, definitely pollen is probably better for them, but protein in general is probably better than nothing if you are trying to manage to have quick buildup for a specific reason, I would say.
Good, good. Thank you. And who else has questions? Any other thoughts?
I wonder if you're saying in general not to combine your protein with your carbohydrate, not just when you're shipping queens.
I guess I would hesitate to make a blanket recommendation about that. I haven't specifically read research either way, but in general, just my knowledge of insects and bees in general is given the option to have the ideal diet that they want in terms of lipid and protein and carbohydrate percentages, they'll sort of optimize that for that needs. And so allowing them to do so is probably a good thing and not forcing them to eat something that they might not want or need to have to metabolize to have access to the other is kind of my thinking, but that is not coming from a data proven place, that recommendation.
Well, and that makes sense to me because particularly like on the foragers, their fat bodies have atrophied so much that they really don't even have the ability to process much protein anymore. And naturally the bees store the syrup, the sugar in one spot and the protein in another, which if it was okay to have it all mixed in, then they might go ahead and do that themselves.
Yeah, and you'll see a lot of times that they will decide not to eat patty that you've put on for whatever reason they're not interested, but they'll still be really taking down syrup. And so I guess, giving them the buffet option to decide how they want to feed themselves is probably better.
Anything else? Other thoughts? You're getting a whole lot of thank yous in the chats. That was really amazing, Abby. That was just a lot of information. And I just think all your research and your experiments in the lab are so interesting. And I'd love to follow you as you go on your queen rearing journey. That sounds like such a fun path to go on.
Yeah, I'm very excited. I love being out with the bees, so.
Okay, I think we're a few minutes early, but I want to thank everybody and give Abby a hand. Thank you, Abby. And we'll see everybody at the business meeting and potluck on the 19th of November. And we'll see you then, everybody. Thank you.
Thanks for
Good
having
night.
me.